Welcome to Tulane. I'm Sandy Stroud. I'm the director of the Sustainable Real Estate Development Program here, and I can't see you. And this is the Sustainability and Globalization Lecture Series. This is the second of 3 this semester. This is a partnership between the Sustainable Real Estate Development Program here at Tulane, the World Trade Center of New Orleans, and the Regional and Urban Studies and Planning Department at UNO. We were really excited about the idea of this partnership because it gives us an opportunity to really branch out and have these sort of broader conversations about sustainability and globalization. The World Trade Center brings some amazing people to New Orleans, and we wanted to take advantage of that. So with that, I am going to introduce Dominic Knoll, who's the CEO of the World Trade Center of New Orleans, who's going to introduce our speaker. So thank you for coming, and Dominic.
Thank you all, as said, for being here. It is an extreme pleasure for us as the World Trade Center to partner with such distinguished organizations as the Tulane University and UNO and also in having such a distinguished speaker today. But before, as you hear, the unlimited natural energy, it is a topic what we should look out for, especially in the future when you all know, you all saw the different trends and charts and so on and so forth. And we believe from the World Trade Center that this is also something for our state of Louisiana we have, as you know, oil and gas and so on and so forth, but this is also an area where we should focus here in the South. From us, from the World Trade Center, we see it also as a knowledge-based energy, and we see it also as you may recall, Germany early on did some investments in solar technology, and so now they're pretty good in it, and they export. And so we see a similar potential here for our state to turn all the knowledge of energy we have into a certain direction and be sustainable, and then also that ultimately we become an export, or we can also export this knowledge. Today, for me, it's an extreme pleasure to have Terry Henry. He's the CEO of Global Perpetual Energy, as you see here. He fits perfectly in this topic because he will tell you several things, and also he will tell you about his short trip probably to Senegal, where he just returned, in showing other countries about this idea, about this concept, and as we just discussed, us exporting knowledge from the United States to other countries. I said Global Perpetual Energy is a U.S. and international company dedicated to develop renewable energy resources to produce power generation utilizing solar, wind, ocean wave, tides, and currents. So it's a whole concept basically, and not just focusing on one. And you will see that it's not just not producing greenhouse gases, but it's also there's no additional external fuel sources needed. So without further ado, I would like to introduce the CEO, Terry Henry, and we're extremely happy that you're here today. Thank you.
Well, first I want to thank the World Trade Center for giving us the opportunity. What he was saying about the World Trade Center, about 5 weeks ago, we actually spoke at the World Trade Center, and we had the opportunity to speak before an ambassador of Senegal, Africa. And Africa they were so impressed with it that when the United Nations came to New York, they asked, the president of Senegal asked us to come to New York and speak before him and show him the system. So once we went to New York, from there we moved, they got us to go to Africa, and they got us to meet with all their top engineers and their physicists and their, just to check all the calculations and the data to make sure that this system will actually do exactly what we say that it will do. And so now they're actually, before the end of the year, they're wanting to do a pilot project in Senegal, Africa. And it's all thank you to the World Trade Center of New Orleans. And then I also want to thank Tulane University and University of New Orleans for letting us be here to speak before y'all. Okay, to speak about energy, the very first thing I need to do is give you kind of like a brief history of transportation. Talk about the ways that we actually use our energy systems right now. Less than 200 years ago, this was our main form of transportation. Shortly after that, we had the steamboats going up the rivers and the canals. Then we had the rail cars. Shortly after, we had the cars. Then in 1912, the Wright brothers made it where we could actually fly across the world. Today, we have production cars that actually move 267 miles an hour across the land. We have cargo containers that will actually carry over 9,200 cargo containers at one time. We have cities on the ocean like the Oasis, has 2,706 rooms, 18 decks. We have rail cars that will pull 4.5 miles of cars full of materials, 662 cars. Pedestrian trains that will travel 357 miles per hour. And then we have the Airbus, the A380, maximum capacity, 853 passengers with 5,146 square feet. And then, of course, we've got the space shuttle, 17,500 miles per hour maximum speed. It's done 135 launches, goes to outer space and back. The reason I tell you about all of that is because of all the fossil fuels that we use in the world, only 30% of our fossil fuels are even used for our transportation. The other 70% of our fossil fuels right now are actually used for our homes, our factories, our businesses, our universities. It's used for everything outside of. In 1879, the first hydroelectric generator was created. By the year 1895, they had the first hydroelectric power plant in Niagara Falls. After that, they created steam turbines, then gas turbines to create electricity, and then everybody knows the nuclear turbines. Okay, now we're going into renewable energy based off of proven technology. Now, the reason I'm pointing this out is because all of the stuff that I'm going to show you on our conceptual energy plant is based off of proven technology that's out there in the world right now. There's a Plomus power wave generator. It's about 585 feet long, 12 feet wide, and it'll produce 750 kW. And the way that this works, as the ocean moves up and down and makes waves, it has hydraulic cylinders that move back and forth just like this. The hydraulic cylinders turn hydraulic pumps, which turns electric generators, which creates the power off of this. It's a very limited action because it only has this movement, so it's like moving almost a chain. Verdant Power Systems in the New York River they've already done 70 megawatt hour testing on their power systems. These systems are 5 meters in diameter, and they're putting a whole grid inside the river right now to generate electricity. The thing about water compared to air is it weighs so much more, and so you can actually create so much more force and so much more energy with your water. The Danish wind turbines. By the year 2020, they're expecting to have 40 gigawatts of power. To give you an idea of how much power that is, the Hoover Dam has about 1.8 gigawatts of power. By the year 2030, they're talking 150 gigawatts of power. These windmills are all off the ocean. The Mojave Desert, 354 megawatt photovoltaic power station. Okay, now we're going to go into the concept based off of these proven technologies. Okay, the capital to build this system based off of these technologies. A gas power plant per megawatt hour costs about $444,000 per megawatt of capital to build. The hydropower system, like the dams, is about $1,156,000 per megawatt. Our system will be about $1,264,000 per megawatt. The wind power, now this is all from the Department of Energy in 2009. The wind power is $1,872,000, solar was $4,458,000, and nuclear was the most expensive at $5,144,000. The cost to produce electricity in 2009 was $53.80 per megawatt hour. Our system will actually produce electricity for $20 a megawatt hour for operations and maintenance. The time frame to build this power plant is about the time frame to build any power plant, which is about 5 years. And it's for a 1,400 megawatt power plant. It will cost about $1.8 billion. The profit off this system, though, after you take the operations and maintenance and the income at $96.10 per megawatt hour, which was the price that we sold the energy for in 2009, gives you a profit of $933 million, earnings before interest and taxes. Okay, this system works off the waves, the current, the tide, the wind, and the sun. This is a power plant out in the ocean. It's about 1,650 feet by 1,650 feet. It has 3 low-head water turbines that turn independently of each other with 3 separate generators off each one. Has windmills on the top side around it. Then it has an ocean blanket system right here. All of the blue that you see is photovoltaic. Okay, as the ocean moves up and down, these pods, each one of these is a pod, are connected to the next pod by 16 different hydraulic cylinders. This is the ocean blanket. So as the waves move, each one of these hydraulic cylinders move back and forth. Turns the hydraulic pump, which turns the electric generator, which creates power and sends it out these slip rings. While that's happening simultaneously, the whole dome is actually solar photovoltaic. So we're creating 2 different sources of power at that point right there. The neat thing about this is, let's say that a hurricane comes through and wipes out Japan. Well, at that point, you could take 200 or 300 of these pods, pull them behind ships, bring emergency power to any landmass. And so that way you can get the country up and going, back on its feet, start giving them clean water again. The pods, each one of the pods, not only is it solar there and works off hydraulic cylinders on the sides, but on the bottom you've actually got a paddle wheel that as the current's moving underneath it, it actually creates more energy. So you actually have 3 different sources of energy off of every single pod. Like that one system right there has over 1,500 pods. The low-head water turbines. As I was saying before, each water turbine has a separate generator. As the water turbines turn, they're going to turn at different speeds because the currents in the ocean are going to move at different speeds. The waves, by the length of the waves and the depth of the waves, the wave power is going to be different at each level. And so we're able to create independent axis. And the currents on the ocean are constantly changing direction, 360 degrees at all times. Every one of the water turbines and every one of the pods have the ability to spin 360 degrees, and that's because the slip ring on top allows all the electrical connections to actually stay connected at all times. Okay, like I said, this is a 1.4 gigawatt power plant. That's based off a megawatt of power being 738,000 pounds per square inch per second. The ocean blanket will actually generate 582.5 megawatts of power. The water turbines will create 612 megawatts of power, and the wind turbines will create 204 megawatts of power. The system out in the ocean will produce the power off a 1,650 foot by 1,650 foot power platform. It transfers over to the land. Once it gets inland, it converts over to AC and then sends it out to the end user. It has no greenhouse gases, no external fuel sources, unlimited natural energy, ultimately reduces the cost of fuel around the world. It saves our Earth's resources that are not renewable. It's environmentally friendly, very profitable, but most of all, it's logical. On July 20th, 1969, we put man on the moon. Ladies and gentlemen, it's not 1969. We're not trying to put a man on the moon. We're taking existing technologies, working them together to create energy.